It is a spooky time of the year, and it is only right that even a game dev related channel partakes in the festivities. Now, my original plan was to have CryEngine, Zenko, and Unity projects built for the project in mind today, but sadly, I was just not able to complete the work and testing in time. I do, however, have one complete and ready to go with one caveat. Tank controls are not properly implemented. If that hasn't given away the topic today, then the video that has been playing of Resident Evil 1 and Resident Evil 0 remasters for PC should have. Yes, folks, today we will be implementing the static cameras as seen in the classic Resident Evil or Biohazard games. I already have Unity opened up so we can begin this adventure. But first, there is a bit of setup I'm going to do prior to setting up the camera in Unity. So, here's a nice track from the Omnific to keep you entertained while I speed up this part. Alright, the level design is complete. The first thing we will do is set our camera and create two more while placing them in the position we want them to be in. We also want to follow the convention I set forth by creating an empty game object at the vector position of 0. The position is purely based on my own OCD about making the parent object be in the center. Drag and drop all three cameras to be in the camera parent object. Be sure to rename the cameras as Cam 1, Cam 2, and Cam 3 respectively. Now we will create a script folder and make two scripts. The first script is Camera Trigger, which will be used to trigger our camera to switch from one to the next. The second script is Player Movement. This script will be used to move the player character. Following this, we need to make sure we add box colliders to all the walls that were created. It should be obvious as to why, but the reason we are adding colliders is to make collisions possible. Without them, you could phase through the walls during gameplay. Next on the list is to create a sphere which will act as the player character. We don't have to worry about adding a sphere collider because Unity does this by default for us with the basic 3D objects. What we do need to worry about is setting the proper position. The next item to complete is create two boxes. I will be changing their size and height to cover a larger area. The reason for this is to make sure the player will trigger the collisions. I will also set the collision type to be a trigger. The reason for this is to ensure that the player does not collide with the object and instead will activate an event. Make sure to name the trigger objects to be Trigger 1 and Trigger 2. Finally, I will create another empty game object with the name Triggers and drag the two trigger objects into it. Again, this is for organizational reasons. I'm going to stop the design from here and move into the code section. This will allow us to have the code completed and make the final touches in the editor. Next on the list is to create a sphere which will act as the player character. We don't have to worry about adding a sphere collider because Unity does this by default for us with the basic 3D objects. What we do need to worry about is setting the proper position. The next item to complete is create two boxes. I will be changing their size and height to cover a larger area. The reason for this is to make sure the player will trigger the collisions. I will also set the collision type to be a trigger. The reason for this is to ensure that the player does not collide with the object and instead will activate an event. Make sure to name the trigger objects to be Trigger 1 and Trigger 2. Finally, I will create another empty game object with the name Triggers and drag the two trigger objects into it. Again, this is for organizational reasons. I'm going to stop the design from here and move into the code section. This will allow us to have the code completed and make the final touches in the editor. The first script we will complete is the camera trigger script. Since we know that this code will allow us to switch between cameras at runtime, we have a basic idea of what needs to be done. We could enable and disable the game objects at runtime, or we could enable and disable the camera components at runtime. The first thing to do is to create a public list of type camera and call it cameras. This will be used to store all of our camera objects. Next up is to create a public string called camName. This will be used to specify which camera we want active at the given time. Create a private void onTriggerEnter method that takes a collider as the parameter. We don't want collisionEnter because that would create a collision event instead of a trigger event. Inside, create a for loop. For int I is set to 0, I is less than cameras.capacity, I++. We are looping through the list of cameras we specify in the editor, which will give it a non-null value. Create an if statement inside of the for loop. If camera square bracket I closing square bracket dot name is equal to camName. We have to remember that we are iterating through a list of objects, which is why we have the square brackets around cameras. Camera square bracket I closing square bracket dot enabled is set to true. Outside of the if statement, create an else statement. Camera square bracket I closing square bracket dot enabled is set to false. This basically says that if the camera's name from within the list is not the same as the string value of camName, then that camera is disabled. If it is the same, enable it. This completes our camera trigger script, and we can move on to the player movement class. The first thing we will do is write public float speed. This will set the speed of our model in-game from the editor. Now we will create a movement method. Inside we'll have several different if statements. If input.getKey, keycode W, inside we will write transform plus equals vector3.forward multiplied by time.delta time multiplied by speed. This will normalize the speed of which the player moves on the forward vector while giving a speed multiplier. If input.getKey, keycode S, inside we will write transform plus equals vector3.back multiplied by time.delta time multiplied by speed. If input.getKey, keycode A, inside we will write transform plus equals vector3.left multiplied by time.delta time multiplied by speed. The final if statement is if input.getKey, keycode D, Inside, we will write transform plus equals vector3 dot right multiplied by time dot delta time multiplied by speed. Lastly, create an update method. Inside of it, write movement. This will allow for the movement script to actually run and update with the game. Whew! The code section is now done. So we can go back to the editor and finish where we left off. Go back to the sphere and add a rigid body component to it and the movement script. The reason for the rigid body is to enable 3D physics to allow for collisions to actually take place and to have gravity enabled. To allow for movement, the movement script does this. Set the value of speed to be about 10. You can go higher or lower if you want, but I find 10 to be the better number. This should give a fairly decent move speed, although just remember that the slower the speed, the scarier you can make the game, in some cases. Click on the first trigger we created and add the camera trigger script onto it. Expand the camera list and add the number 3 to the size. This will set the list to have a value of 3 cameras. Add all 3 cameras to this list. The string value of cam name should be set to cam2 for the first trigger, and on the second trigger, the cam name should be cam3. Finally, uncheck the mesh renderer from the 2 trigger objects. This is so that it will not render the object, but the collision detection is still enabled. Click the play button and you will see that we have static cameras enabled. But just remember that we did not write the code for controls not based on camera position, so some controls will be reversed at times. So here's my challenge for you guys. Rewrite the movement code to be proper tank controls, or movement not based on camera position. If the player presses the forward button, the model should always move in the forward direction. I want to give a warm shout out to my Patreon supporters and to everyone in my Discord server that gives me ideas and criticism on my videos. I also want to thank all of you that watch my content. And now, an ad about NordVPN. Do you live in a country where certain websites are blocked? Do you live in the EU and are in fear of Articles 11 and 13? Do you just want to protect yourself online? Then get NordVPN. Choose which service you want to connect to and use it on PC, macOS, Linux, iOS, and Android. All for the low price of $3.99 US per month. They accept PayPal, Visa, MasterCard, Amex, and Discover credit cards. They also accept cryptocurrencies as well. Bitcoin, LTC, Dash, Ethereum, XMR, ZEC, and XRP. Finally, if you don't have access to any of these, they also accept Alipay, UnionPay, and Mint. I use the software, and if you need a VPN, you should too. Link is in the description box below.